Bismillahirrahmanirrahim. So in this video lecture I'm going to show you how to check different diagnostic tests in EViews. So I already have the data for 50 years. Again, Phillips curve, randomly taken unemployment, inflation rate and government debt. So basically three independent and one dependent variable. So this is a time series data for 50 years. Again, so we have to move for EViews first. So here is the EViews. So we already noted how to import data. So open as a foreign file. On desktop I have data for economics, data for Phillips curve, yes, and open it. Next, then finished. So in this way we get the data for EViews. So first run the regression, unemployment, then inflations, let's say main principal determinant rate, then government debt level. So these are our variables. So select right click and open as equation. So I want to carry this coefficient terms after dependent variable, so put C over here. Now this is our method is least square and sample is from 1 to 50, mean 50 years. This is the regression result we have obtained. So basically before moving to the test, different kind of test, you have to check the significance. So yes, there is three variables are significant: inflation and trade are significant, and government debt is insignificant from probability as we compare it with 0.05. If it is less than 0.05, it is means significant. These two are less than 0.05, this is greater than 0.05, so it is government debt level is insignificant, having no impact on our unemployment, which is dependent variable. So dependent variable here is unemployment. So these are the coefficients, you can interpret it. So how you interpret this inflation? So the interpretations of this coefficient is that if 1 unit increase in inflation, if 1 unit increase in inflation, then our unemployment will be decreases by 0.0346 unit. So why we decreases? Because there's a negative sign. Again, trade, if 1 unit increase in trade, then unemployment will be decreases by 0.29036. Basically so if you want to write this in model form, so I will show you. This is basically multiple regression model because we have many independent variable. This is, you may consider y independent variable, dependent variable as your unemployment, beta naught is your C, in this case constant term, and beta 1, which is the coefficient of first variable, we say inflation, and this is the second variable. X2 is, let's say, trade, and beta 2 is the coefficient of trade, and beta 3 is the coefficient of government debt level. And we already know that when we run the regressions, then this error term becomes 0. So this is multiple regression case. After getting multiple regression case, there is another thing you need to check it. Normally there's a rule of thumb in econometrics. We say that if Durbin-Watson should be greater than R square, if R square is greater than Durbin-Watson, then we say that regression is spurious, or there is the wrong relationship. But here R square is less than Durbin-Watson, so this is the not spurious or not wrong form. This is the correct regression. Again, so how you check the autocorrelation and heteroscedasticity? Basically heteroscedasticity says that different variances are not constant, variances are changing, and autocorrelations means error terms, legs of error terms are correlated, means. So how you check the error term? Heteroscedasticity and other things from residual diagnostics. Go first, again view. After view, then there is the residual diagnostics. In a residual diagnostic, there are many tests. Heteroscedasticity test in order to check heteroscedasticity, and serial correlation LM test in order to check autocorrelation, and histogram normality test in order to check either this is the normality test, or normal or not normal. Normal means the graph or the graph should be bell shaped. If there is the bell shaped, so it is a normal. So these are the basically we are assuming from the assumptions of classical linear regression models in there. So homoscedasticity, variance is zero, there is no problem of autocorrelations, and the model is normally distributed. So they, if their condition satisfy, then our regression is correct. If regression is correct, then the other steps at the and at the last, our forecasting is better. Better forecasting means better prediction. Better prediction means better result and better policy. So I want to check first heteroscedasticity. So click on heteroscedasticity. So there are many methods. The most famous method is Bruce Pagan Godfrey and White test. But first check it on Bruce Pagan Godfrey. Click on OK. So this is your heteroscedasticity test, which is with the method of Bruce Pagan Godfrey. So in this method, what the relevant thing is for you in order to check either there's a problem of hetero or not. So first we have to set null and alternate. So I already set null case of heteroscedasticity. In this case of heteroscedasticity, if you see the null hypothesis is joint hypothesis, basically beta 1 coefficient of, let's say in our case, inflation, beta 2 which is the coefficient of trade, and beta 3 which is the coefficient of government debt level, all equal to 0. We set our null hypothesis in this format, and we say if these are equal to 0, it means no heteroscedasticity, means there is the homoscedasticity. And alternatives, we say at least one of the betas is not equal to 0. So if we reject the null, then there is the problem of hetero. If we accept the null, so there is the no problem of hetero. So let's move to our regression result, and we have to check this thing. So the probability value is here 0.081, which is greater than 0.05. So we do not reject H naught in this case. When we do not reject H naught, means the statement in the H naught null hypothesis is correct, and we are not going to reject it. It means there is no problem of heteroscedasticity. So there is no problem of heteroscedasticity in this case. But if you want to check autocorrelations in the either there is a problem of auto or not, again open as equation. So yes, no need to make it modify the modification. So again, residual diagnostics, and go for serial correlation LM test. Lake specification is by default 2. Okay, no need. Again 0.09. So in this case, again null and alternate. In case of autocorrelation, so H naught is beta 1, beta 2, and no autocorrelation, and at least one of the beta, so there is a problem of auto. In this case, again H naught should not be rejected. H naught means null hypothesis should not be rejected. But if you check over here, the probability value is 0.09. It means there's a problem of autocorrelations. Why autocorrelation? Because we reject H naught. When we reject H naught, when we reject H naught, means there's a problem of autocorrelation. So this is all about autocorrelation and heteroscedasticity.